Good morning. Like you said, I'm Cortney Kidd, and I'm from Floyd Central High School. The biggest focus that I have decided to focus on with my students this year is the transition from old school science to actually leading forward into the next generation science standards. And with that being said, I actually designed this grant to help my student communication in science class. I don't know if any of you are science teachers, but in the last couple of years, we've actually made this transition to where we're trying to take out the rote recall that we've actually seen in science for so long, where it's what enzyme does this, what part of the cell controls this, and we're actually trying to get our students to where they actually have an interpretive means of study, to where they're doing student design and they're actually doing analysis of data, stuff that actually modernizes the things that they're doing in class. So what I've decided to do with this grant was I'm actually implementing something called a CER strategy with all 4 of my biology classes this year at Floyd Central. With a CER strategy, what that's actually representing is claim, evidence, and reasoning. As a teacher, one of the biggest faults that I see with my students, usually with content, is they think when they're providing me with scientific evidence or they've done a lab and they've gathered data, they think that once they make a general statement of, I found this from doing the experiment, they think they've actually justified that, and they think they've also given me the reasoning in that same exact statement. What I'm trying to do through this grant is actually develop a technique with my students where they understand that it's okay to make a firm statement, like a generalized statement of the overall research that they've done, but then they also have to give me evidence that backs up their claim. So what I actually am planning to do with the funding for this, I planned it around my cell unit, my cell biology unit, and what my students are going to be doing is it's a 5 separate lab activity strategy, and it actually incorporates all of the performance standards that they see in the next generation science standards. So one of the first activities that I actually purchased the materials to do was a patterns of diffusion kit. Through the patterns of diffusion kit, what my kids are going to be allowed to do is they're actually going to be doing a lab to where they can monitor different sizes of cells, and they can actually make predictive patterns about the absorption rates that cells see. They're going to be able to see like how much osmosis, what's the pertainability to that cell as far as how does that cell get nutrients. And then the link that they're going to make to that, they're actually going to do some calculations, and they're going to look at rates of absorption. The connection that I'm going to have my students to make with that, with the generalized statement, is how we're treating bacterial infections. One of the things that the kids love to talk about, things that they're going to incorporate on a daily basis. And every year, it seems like around sports time, we deal with that conversation of MRSA. So the link that I'm actually going to make with that lesson is we're going to look at size-pertaining cells. They're going to take a MRSA infection, and they're going to predict how much antibiotic they should actually use to treat that. So not only are they going to make a claim-based statement from that, they're going to have evidence from an actual hands-on activity that they can relate that back to. The second thing I'm linking is something called a semi-permeability nature. Another connection that the students will be able to make with this one is for people who are on dialysis. Very high prone topic for the students once they start talking about that. A lot of times they've had family members who've had dialysis treatments and things like that. So with some of the funding for this, after I split it into the activity kits, I actually had enough funding to buy dialysis tubing. So not only do they get the real life exposure to what dialysis tubing actually looks like, they actually get to find out what happens during that process. But we're going to do a permeability lab where they actually take liquid materials that are going to resemble our blood. You can buy fake lab kits that are blood kits through Carolina. That's what I'm doing with the money. And they're actually going to filter the blood and look at permeability natures and talk about how certain things can pass through membranes but other things can't. The importance behind that, I guess the significance for that is so many times we teach students content and it's not really a level playing ground for them because we're teaching them things that are kind of out of scope. It's stuff that's kind of out there, especially in biology where everything's microscopic. I can't really get my students to see what I'm talking about, but by using strategies like these, I hope that that actually eliminates that and they can be better prepared when making claims about that. The next kit that I purchased was a volumes to ratios kit. In this section, my biggest thing is having my students form predictions. And I hope at some point in every class, not just biology, you're all having your students write predictions before they make claims, kind of like a hypothesis in nature. But the problem with that is a lot of times our kids want to kind of alienate away from that let me tell you what I think, because I'm afraid to get it wrong. So many times students are afraid to fail at something. They're so afraid of that first attempt. Through the use of these strategies and by having them make predictions before their claims, I'm hoping that they're actually going to find, hey, it's okay for me to fail at something. It's my first attempt at something. I can be wrong, but I can still learn from that. And then the last aspect, or the lab part of this that I'm looking at, I purchased some microscopy lab sets. I purchased a onion mitosis lab set to where they can actually look at cell division. And then I also purchased a set of bacterial slides. The specific sets that I purchased, I kind of inclined it so I could actually link back to the 3 activities that I've already talked about, for the purpose of, like when I was talking about the MRSA later, it gives them another connection back to that, because the sets that I specifically picked out, I picked out ones that had varied cell types on it, so they can also look at patterns and trends. So basically what I've done with this lab set is I've used the funding to help me purchase things that would allow me multiple years of use. Like, I didn't purchase any materials that I wouldn't be able to use probably 6, 7, 8 years and actually get the same kind of content from it. But I've also opened doors to my students so they can actually apply the things in science that we're speaking about. They can actually visualize it and see it before they make these claims that I'm so persistent in them making right now because of the next generation science standards. And again, a lot of people may question, why are we pushing so much towards doing in science rather than just knowing? It's because that's our new testing mode. Our new testing mode is having students do science through course tasks and things like that. They have to be hands-on, they have to be involved, and they have to have a concept of understanding rather than just knowing content that they can apply. So my hope is that throughout the course of this grant over the next month and a half when I'm doing my cell unit, is that by having my students do these strategies, they can actually go out, they can provide explanations to other things that they're going to encounter throughout the rest of the year. Questions? Yes, ma'am. Yes. 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 It is. All of the activities will be small group based just because of funding. I mean, that's kind of a general activity. But one of the things that I do, I intentionally group my students depending on the activity. If it's one where I know I'm going to have somebody that is willing to step up and take that, I always try to group that student that is willing to do that. And sometimes I do intentionally group based on level, because sometimes my higher students will take more from a lab and they'll run with something and they'll reach a concept that my others won't. So I do intentionally group depending on whatever the strategy may be. But one thing, and I neglected to mention that, I do inquiry-based labs. All of the labs that I purchase, they'll have the same materials. I don't set the design up for them. Like the cell inquiry where they're doing surface area and volume, like cell size, I literally will set out, and I think I have enough to do 6 different sizes. I set out the materials for them. They prepare the investigation. I do have them approve it with me, because sometimes they'll design something and they'll miss a key aspect of it, but I let them do their design. So when I say they're afraid to fail, sometimes it's because they don't want necessarily to say, well, your lab didn't work. So I am working to eliminate that, but at the same time in science, they have to be willing to realize they are going to hit walls and they are going to fail at times. That's just the nature of the new science standards. I mean, they have to all get to that point. And I will not let the same student do presentations every time. With 5 activities in this unit, usually I'm looking at about 30 to 32 per class. I'll have 5 to 6 groups, so every student will have a presentation component.